Now we're going to go a little bit more in depth on transactions. So what does a transaction actually look like? You have inputs and outputs. And inputs and outputs both use something called UTXO, unspent transaction outputs. Transaction, you'll see this all over the place, is abbreviated to TX, transactions. Okay, so in your wallet, you actually, in a physical wallet, you have paper money, and then you have a bunch of coins of various sizes and values. In a Bitcoin wallet, it doesn't actually store individual whole Bitcoins. What it does is it stores UTXO of various sizes. And to send value, so let's say this is 0.75 Bitcoin, this is 0.5, this is 0.7, say 0.1, 0.4, 0.3. Okay, you've got all this random amounts. And 1 Bitcoin is equivalent to 100 million Satoshi. Okay, so UTXO are actually expressed in Satoshis, but what most people pay attention to are Bitcoins. So UTXO is stored in your wallet in all these different chunks. And then if you want to send 1 Bitcoin, you have to add up inputs that equal at least 1 Bitcoin. So if you wanted to do it, you could say, let's do 0.75 plus the 03. So our first input will be the 0.75, and the second will be 0.3. So this totals to 1.05 Bitcoin. The output is 1.0, and then this leftover amount, 0.05, is the transaction fee, and that goes to the miner. So this is Alice's wallet, and she's sending this to Bob. And what Alice does is she writes up this transaction, and then she signs it using her digital signature. And then she sends the transaction plus the digital signature. So here's the transaction, and there's a little bit extra down here, which is the signature. Okay, this goes to the miner. And then the miner checks, okay, it's signed. That signature matches the other information in here, Alice's address. And so, okay, this is a legit transaction. And the miner adds this transaction to the current block and keeps this, we'll call it a 5-cent fee. And so how does the miner make money? The miner makes money through the 12.5 Bitcoin they earn from mining this block. And then they also capture all the little fees. You know, let's say there's 10 fees in here, and there's 10 transactions in here. So the miner keeps that 12.5 Bitcoin, and let's say there's another 0.5 Bitcoin in fees. So they make 13 Bitcoin total from mining this block. Sometimes things don't add up properly like this. So you could actually add, I'll do another example. You could have your 0.75, you could have your 0.7. So this adds up to 1.45 Bitcoin. You want to send 1 Bitcoin to Bob. You want to leave a 0.05 fee. And the reason I put it in dots is because to save space and to save data storage space, this fee is not actually included. It's the miner figures out what the fee is by what's the amount of money that's left over. So if we want to split this up into 3 ways, we want to send some to Bob. What you do is you send the 0.4 back to yourself. To Bob from Alice. Okay, so this 0.4 actually is sent back to Alice's wallet. And the 0.5 is sent to the miner. So this UTXO and this UTXO are inputs, and then this UTXO is now a new piece of Bitcoin in Alice's wallet. So now there's 2 0.4 UTXOs in Alice's wallet, and these 2 are now gone. And they've been turned into this 1.0 chunk of UTXO in Bob's wallet. Okay, so and there can be literally 12, 2 dozen little tiny pieces of UTXO, a 0.0001 UTXO, and you could throw that in here also, and then that could go into the fee. You could send that back to yourself. Okay, so that's in depth what these transactions actually look like. Okay, you write it up, you make sure you have your fee. If there's any left over and change, you send it back to yourself. You send the transaction plus your signature of the transaction. And what that means, that signature of the transaction makes it so that the miner can't go into the transaction and say, oh, that 0.4 that you're going to send back to yourself, actually, I'm just going to take that. That's going to go to David the miner. You can't do this because then this signature will no longer match the transaction, because the transaction has been changed to send this UTXO of 0.4 to David's address. That changes some of the data in the transaction. Signature is no longer valid. And so because it's no longer valid, it's going to be an invalid block. And the other miners, when they get this block from David, they're going to say, no, that transaction isn't valid. We're not going to use that block. That's an invalid block. And so that's how Bitcoin prevents a miner from stealing money from transactions.